For this lesson, we're going to look at higher derivatives. So you can take the derivative of a function as many times as it's allowed. For example, let's say I told you I had function f of x is equal to x to the fifth, and I asked you to tell me what the derivative of that function is. So the derivative. So the derivative, that's easy. That's just 5x to the fourth. Well, what if I ask you for the second derivative? In other words, the derivative of the derivative. So you can keep on going. The derivative of that would simply be 20x cubed. What if I ask you for the third derivative? Or in other words, the derivative of the derivative of the derivative? That would be 60x squared. Or even, what about the fourth derivative? Then that would be 120x. Or what about the fifth derivative? That would be 120. Well, what about the sixth derivative? Well, then that would be 0. In fact, you could even keep on taking the derivative now because it doesn't matter. The derivative of 0 is always going to be 0. So the derivative to the nth power, it wouldn't matter. It would still be 0 at the end of the day. What I want to get at is that you can continue to take the derivative as necessary. In the context of real life, typically, if you have an original function, f of x, that's what we would consider our position function of an object, and then its derivative is known as the velocity function, and then the second derivative is known as its acceleration function. So in other words, the derivative of position is velocity, and the derivative of velocity is acceleration. So you just at home, you can take derivatives repeatedly as needed. So for example, let's say I wanted you to calculate third derivative at -1 for the function f of x is equal to 3x to the fifth minus 2x squared plus 7x to the -2. You could easily find that by first taking the first derivative, which would be 15x to the fourth minus 4x minus 14x to the -3. Repeating that, taking the second derivative, getting 60x cubed minus 4 plus 42x to the -4. And taking it one more time, the third derivative would be 180x, that would be 0, minus 168x to the -5th, and then substituting in 1 for x, and so 1 to the -5th power is still 1. So that just gives me 180 minus 168. So that should give me an answer of not minus sign there, right here. Derivative of that should have been positive somewhere. 180x, it's a -1. That's why, sorry, the -1. So -1 to the -5th power is still -1, so positive. And so then 180 plus 168, that would give me 8 and 348. So that would be the answer for that problem. So do watch out for your signs. Right. Another example is, let's say I wanted you to find the first 4 derivatives of the function y is equal to x to the -1. Well, the first derivative would simply be -1x to the -2. The second derivative would simply be 2x to the -3. The third derivative would simply be -6x to the -4. And then the fourth derivative would simply be 24x to the -5th. And so you could just repeat that on and continue it on indefinitely, even applying the product rule to it. So for example, let's say I have the function f of x is equal to x e to the x, and I ask you to find the first 3 derivatives. Well, the first derivative would simply be product rule, so first times derivative of the second plus second times derivative of the first, so that would be x e to the x plus e to the x. So that would be my first derivative. The second derivative would then just be the derivative of that, and so that will be the product rule again. So I've got to do first times derivative of the second plus second times derivative of the first, and the derivative of e to the x is e to the x. Clean this up, so I get x e to the x plus e to the x plus e to the x. That gives me x e to the x plus 2 e to the x. Then if I want to take the derivative one final time, the third derivative, again, product rule. So I'm going to have first times derivative of the second plus second times derivative of the first plus the derivative of 2e to the x will just be 2e to the x. clean this up, I'd get x e to the x plus 1 e to the x plus 2 e to the x. Combine my like terms, that would give me x e to the x plus 3 e to the x. And so that would be my first derivative, my second derivative, my third derivative of the original function, x e to the x. Now let's actually talk about context problem. So let's say that I was talking about acceleration due to gravity. So let's say that I had a function, a position function, s of t is equal to 12t minus 4.9 t squared, and this function models the position of a ball that's tossed vertically up in the air, ground level, initial velocity of 12 meters per second. So what if I ask you to find the velocity function? So the velocity function is simply the derivative of the position. So velocity is simply the derivative of the position. So that means the velocity function will just be 12 minus, and then the derivative of 4.9 times 2 would be 9.8 t. So that will be the velocity function. If I wanted the acceleration function, that would be the derivative of velocity, which would technically be the second derivative of the position function. And let me clean that up a little bit. So that means that the acceleration of the ball at any given time is negative 9.8 meters per second squared. So in other words, that is the ball's acceleration at any given time that I threw the ball up into the air and it was falling down. But that's its constant acceleration. And that actually goes back to Galileo's experiments with throwing objects from the Leaning Tower of Pisa, and realizing that all things accelerate at a constant rate towards ground, towards the earth, and that's gravity. So if you've taken physics or you've taken physical sciences, you'll recognize the negative 9.8 meters per second squared. That's acceleration due to gravity, due to the Earth's gravity. Anyway, that's it for today's lesson.